Yeah, hi there. In this tutorial, we are going to cover data wrangling in Python. So, what is data wrangling? Data wrangling, it's a process of cleaning up and unifying messy and complex data sets for easy access and analysis. So, basically it's a process to clean up the data, to structure the data, and enrich the raw data that we have received into a desired format, so that we can use this new formatted data for better decision making. As you know, today we get data from different sources, and data is not necessarily structured. It could be semi-structured. It can have some anomalies, like it can have missing values, it can have some duplicate rows, it can have some outliers, some wrong values, maybe due to some error in the process. So before we actually use this data to build any model on top of it, we have to make sure that the data that we are going to use for model building is clean and it's tidy, and this is what all we do in the data wrangling process. Okay, so we will first start with dealing with the columns that have very little variance or no variance. So what I mean is, let's say if we receive data from a file and it has a number of columns, and let's say if there is some column in which it's the same value for all the rows, uh, uh, that is the column is constant, or you can say static value for all the rows, then such column does not contribute much if you're going to use this column for the modeling purpose, because there is no change. It's like static, so there is no variation in it. So such columns which do not have any variation are called as zero variance predictor, because such columns are not very useful for the modeling purpose, so we can drop such columns. Okay, so what I'm doing is, first I'm importing the libraries numpy, pandas, matplotlib, cborn, and another library, url lib.request. This is to actually read the data from GitHub. Okay, so I'm having data in my GitHub folder. From there, I'm using this URL, going to load the data. So I'm using np.loadtxt function, and within that I'm passing this URL to URL open and specifying the delimiters, comma, loading the data into this data object. If I check the type of the data, it's an ND array, NumPy ND array. The shape is 93750, that is 937 rows and 50 columns. Okay. Now we can convert it into a data frame, store it in a data frame, like by doing pd.data frame and passing that data array to it, and as a result we get a data frame which we are storing it in df. Now if I check the shape of df, it's again 937 rows and 50 columns, so the shape is matching of data frame with the numpy array. Let's check the first three rows of that particular data frame. So this is what we have, and if you see, notice that this data set doesn't contain any header. Okay, that is fine. Now what we are going to do is, we want to in this exercise, first we want to find out the number of unique values each column is having. So based on this we can find out whether any column is a static or not. Okay, so how do we find out number of unique values for each of the columns? We can use df.nunique and storing it in another object called unique counts. And if I see the first few records of unique underscore count, it goes like this. So it means the zeroth column in the data frame has 238 unique values, the first column has 297 unique values, second column has 927 unique values, and so on. So from this we are interested only on those columns which have only one unique value. So if it is having any column having only one unique value, it means it's the same value that is there in all the rows. So that will be our zero predictor column. Okay, zero variance predictor column. Okay, so okay, so what I'm doing is, I'm just filtering on the basis of unique counts equals to 1. So this is the unique counts, is a series in which we had gathered the unique count for each of the columns. I'm putting a filter where this unique count equals to 1, and passing that filter to the unique underscore counts again in the series. So what we get is 22 1. What it means, 22nd column has only one unique value. So This is actually a one which is a zero variance predictor column. Okay, now along with this, we would also want to have a look at the columns which have very few unique values, that is, which are not exactly zero variance predictor columns, but which are very close to zero variance predictor columns. Let's say if in a data frame of 10,000 records, there is a column which is having only maybe two or three different values, and if we somehow know that okay, this doesn't contribute much to the for the modeling purpose, then we can also drop that column. Okay, but we need to be careful, yeah. So what we are going to do is we are going to find out the in terms of the percentage, like what is the percentage of unique values each of the column is having. So what I'm doing is df dot n unique. It's the same thing that we did earlier. Now I'm dividing it by the length of data frame and multiplying it by 100 to get the percentage. So we get for each of the column what percentage is having the unique values. So zeroth column has 25% unique values. First column of the data frame has 31% unique values, and so on. Now we are interested only in the only for those columns which have less than 1% unique values, that is, which is very close to zero. So that we can again find out using now this time we are calculating it in under an object called unique underscore per, which will be a series. So just filtering it unique underscore percentage less than 1, and we are interested only in the index, so it will give the column index. So these are the column indexes which are having unique values less than 1%. So let's say we want to somehow we the requirement is to drop such columns. Then we can drop this column based on this index. So the way to drop is df dot drop, that is data frame dot drop, which is a function, and the index which we are trying to drop is column underscore index. Axis is 1 because we are going to drop the columns, and in place equals to true. So the changes will happen within the data frame, and then if we check the shape we get 937 and 39. So it means number of rows are same, but we dropped from 50 column to 39 columns. So 11 columns got dropped because those were the columns which were having very less variance, or nearly zero variance, that is less than 1% variance. Okay, so this is one type of cleaning that we can do. Another cleaning that is required is data deduplication. So quite often we get data in such a way that some of the rows within the data set are duplicate. So in such case we want to retain only one of those duplicate rows and want to remove the other duplicate rows. Let's say there is a value which is coming in three instances, then we would retain only the one instance and we will drop the other two instances. So we can retain the first instance of such duplicate value, or we can retain the last instance of that duplicate value. By default, it retains the first instance of the duplicate value. Okay, so let's say I'm reading data from the GitHub location. The file is iris.csv, loading it into a data frame iris directly using pd.read csv function, and checking the shape. It is 150 rows and 5 columns. Okay, now let's see whether this data frame contains any duplicate or not. So we can call the method duplicated, that is iris, that is data frame dot duplicated, and it will return true or false. If the row is duplicated, it will return true, otherwise it will return false. So I'm passing this logical condition to this iris data frame, and then what we get is the duplicate records. So because it is duplicate, so we would want to only retain the first instance and drop the other instances which are causing the duplicacy. So how to do this? Iris, that is data frame dot drop underscore duplicates, and keep equals to first, that is I want to retain the first occurrence and drop the other duplicates. In place equals to true, so changes should take place within the data frame. Okay, now this is done. Now I just want to cross verify whether all the duplicates are removed or not. Then I can say data frame dot duplicated dot any. That is, if any duplicate is still there, it will return true, otherwise it will return false. So since it returned false, it means there is no duplicate within the data frame now. Now next type of data wrangling we do is the outlier reduction.